In this tutorial then, we're going to look at algebraic fraction equations. So let's have something like, let's keep it nice and straightforward to start with. Problem A then, let's have 3 over x plus, let's keep it pretty much the same, so 2 over x equal to 4. Now in this situation, and we've got a previous video that you've probably seen that shows you how to do this, so if not, go and have a look at that. But we've got a common denominator here that we're going to use. The common denominator is already working itself out, so the common denominator is x, so we've got 3 plus 2 over x equal to 4. And now if we've just multiply through by x, and just to save space here, I'm going to just erase it. Then we'll get the x on the other side. Therefore, x equals 5 divided by 4, which is 1 1/4. So hopefully that was a pretty straightforward calculation for you. If not, go back to previous videos and have a look at how to do this. Now, once we've got that skill under our belt, we're going to get more complicated fractional equations, and the sort of equation that I have in mind is something that tends to look more like this. 4x plus, let's say, 2 plus, let's say, 3 over 2x minus 1 equal to 2. Okay, now this is in fact a quadratic equation. So eventually we're going to have to solve this using our quadratic equation tools and techniques. But first of all, we've got to rationalize the denominators. How are we going to do that? By finding a common denominator. So our common denominator, let's write the fraction bar first. So our common denominator is going to be the product of these two. So you simply multiply these two together, and that's going to give you a common denominator of x plus 2 and 2x minus 1. So that's the first step. And we saw this in a previous video, so I'm not going to spend too long on going through this simplification of the left-hand side. But now that we've got a common denominator, we can see that the 4 must be multiplied by this 2x minus 1 to give us this expression here. So it's going to be 4 times 2x minus 1 plus, and then the 3 has to be multiplied by this x plus 2. And that gives us the basis of our simplification. We've now got 8x, 4 times minus 1 minus 4, plus 3x, 3 times 2 is 6, all over. And if I multiply out this and just FOIL it, then we'll gather like terms in 1 minute. So x times 2x is 2x squared. The outer is minus x and the inner is 4x. And then 2 times minus 1 gives me minus 2, equal to 2. Okay, gathering like terms then, I've got 8x plus 3x give me 11x. So 11x minus 4 plus 6, or 6 minus 4, is plus 2, positive 2 there. So that's my numerator. My denominator is just these middle terms that need simplifying. I'm just going to straighten up that fraction bar. It's a bit wobbly. It's a bit better. So 2x squared, nothing to do there, but 4x minus x is going to be plus 3x, and then minus 2, equal to 2. Now, the final stage in the process is you want to rationalize the denominator. You don't want to certainly you don't want a quadratic in the denominator, so we're trying to get everything into the numerator, in other words. And we simply do that by multiplying by this expression. So we're going to end up with 11x plus 2 equal to 2 times 2x squared is going to give us 4x squared. 2 times 3x is going to give us 6x, and 2 times negative 2 gives us minus 4. Now, gathering everything over to the left and putting it equal to 0, in fact I'd gather it over to the right and then swap it around, but same idea, so just skipping a step there, just make sure you're clear what I'm doing here. We've got 4x squared plus 6x, then bring that 11x over, minus 11x, so 6x minus 11x gives us minus 5x, and then we've got minus 4 minus 2, okay, so we're subtracting 2 from both sides, giving us minus 6 equal to 0. And that's all the simplification done, and now we have a straightforward quadratic equation exactly like we had before, and this one looks pretty easy to solve. I am though going to use a method that we developed in one of our final videos on quadratic equations, which is to use the discriminant. Now the discriminant, if you remember, is b squared minus 4ac. That's the bit under the whole quadratic formula that, we'll give it that symbol delta, that's the bit under the whole quadratic, in the quadratic formula rather, which is under the square root sign, and it's a very useful little construction and something we can work from, easy to remember, and it tells us whether we're going to in fact factorize or use the quadratic formula for this. Well, let's have a look. What is the discriminant then for this particular expression? So if we write it here, the discriminant is going to be b squared, so that's minus 5 squared, 25. Okay, that's that bit, minus 4, and it's best to write these out, 4 times 4 times minus 6. So 4 times minus 6 is going to give us minus 24. Minus 4 times minus 24 is going to give us positive 96. So we've now got 25 plus 96. Well, if I add 4 to that to give me 100, then I must subtract from here to give me 21. So that's going to give me 121. And 11 squared equals 121. So we know we can use factorizing or the quadratic formula, and I'm going to choose to factorize this now to get my solutions. So in fact, why don't we use the same color? Now, my little working out. Okay, so we've got product and sum, so minus 24. Again, if you're not sure what I'm doing here, go to previous videos, make sure you learn that first before attempting something like this. So minus 24. Now our sum is minus 5. So we're asking ourselves what two numbers will multiply together to get minus 24, but also will sum together to give minus 5. So two factors of 24. Well, 1 and minus 24 is a factor that will not sum to minus 5. 2 and minus 12 then. Again, we're not getting to minus 5. 3 and minus 8. And that produces our minus 5. So it's 3 and minus 8. If I do a little grid here and work myself backwards from the grid, like that, then, and in fact if I go back to my blue pen just in case this goes over and you'll be able to see it clearly. Okay, so now I can fill in. I've got 4x squared here. I know I've got minus 6, but it's how this middle term splits that I didn't know before. I do now. It's minus 8x plus 3x. So 3x there. Okay, so looking at that, I'm going to put 4x here as one of my sides. X up here. 4x times x gives me 4x squared. Now x times something gives me 3x. Well, x times 3 will give me 3x, so it's 4x plus 3. And I've got 4x times something gives me minus 8, so that's going to be minus 2. Minus 2 times 4x gives me minus 8x. And just to double check on the fourth quadrant, minus 2 times 3 minus 6, so that's got to be right. Okay, excellent. So that's split my middle term, which means I can factorize. And I've got my factors here on either sides of my grid. So I've got x minus 2, and I've got 4x plus 3 equal to 0. That must mean x minus 2, using the zero product principle, x minus 2 equals 0, then x must equal 2. Or 4x plus 3 equals 0, which would mean 4x equals minus 3, so it's going to be negative. X will equal minus 3 divided by 4, or minus 3/4. So I've got my two values for x there and solved my fractional equation. Okay, let's do another one. Let's erase this first. Keep my discriminant up in the top right hand corner, I think. A very useful little idea. And again, important to check whether you're going to use factorization, if you like using factorization, or the quadratic formula. And some people, of course, say, well, why not use the quadratic formula all the time? And perfectly possible to do that. Okay, so let's start the next problem here. So what are we going to do? Well, let's not do anything very different so that we get used to this process. So let's try, yeah, let's just have 4 over x. I was going to do something larger, but let's just try 4 over x minus, I'll just shorten that fraction bar actually. Looks a bit funny. So 4, there we go, over x minus 3 over 2x plus 3 equal to 1. And I'm deliberately putting it equal to 1 because it just will make things easier, and I'm probably going to skip a step here as well, because as we get used to this process it becomes quite a bit quicker. Okay, so first step, I've got my common denominator. Well, that's going to be x, 2x plus 3. That's the first step done. And I use this expression to get my numerator on the left hand side here. And I use this x term to get my minus 3 times x minus 3x equal to 1. Now multiplying out, I've got 8x, 4 times 3 is 12, so plus 12, minus 3x in the numerator here. Okay, and in the denominator I'm going to get my quadratic forming now. I've got 2x times x, so 2x squared, and x times 3 is going to give me plus 3x. There we go, equal to 1. Now, I need to gather like terms. I've got no gathering like terms to do in the denominator here, so nice and straightforward. In the numerator, though, I've got, well, what have I got? 8x minus 3x. I've got 5x plus my 12. And now, because I know I'm going to multiply through, I might as well do it in one step. If I multiply through, that's going to eliminate, or rationalize the denominator, eliminate this expression from the denominator on the left-hand side. And it's just 1 on the right-hand side, so I can simply write it out again on the right-hand side, like this. Okay, so we've got that far. It just remains to gather like terms. So that becomes 2x squared plus 3x minus 5x. So let's make sure we've got the negative sign here. Minus 2x then. So 3x minus 5x is minus 2x. And bringing my 12 over, so subtracting both sides by 12 gives me negative 12. And we put it all equal to 0. So the only kind of interesting thing that makes it just a little bit more complicated than the last one is I'm going to introduce a step here that we didn't have to do before. So here we've got 2x squared minus 2x minus 12 equals 0. And it's a good idea at this stage to take out the common factor of 2 on the left hand side, because if we're equal to 0, well, it will cancel out on the right. You'll see what I mean as I work through it. So divide this expression by 2 and I get x squared. Divide this by 2 and I just get minus x, and divide minus 12 by 2, I get minus 6. Now I've got to divide 0 by 2. Well, 0 divided by 2 is simply 0, 0. And now, again, I can think about my discriminant. So, very quickly, my discriminant is going to be, well, what's it going to be? B squared minus 1, that's going to be 1. Minus 4. So, minus 4 times 1. And then my C term is minus 6. And so these minuses are going to cancel out. We're going to get 24 then here, plus my 1. So that's going to work out as 25. 25 is a square. So we've got 5 squared equals 25. And if it's a square, I can factorize. So I will. I'll factorize straight away. In fact, with something as simple as this, I don't need to go to all the bother I went to before. I can simply do it by kind of trial and error process here. I know that my first term has no coefficient, so it's going to be x times x, and so there's no other possibility here. I know that my last term is minus 6, so it's going to be the product of 2 and minus 3, or 3 and minus 2, so I can put 3 here and 2 here, for example. It just remains to say, well, where's my minus and my plus going to go? Well, I want negative x, so it's going to be minus 3, and it's going to be positive 2. And just checking, if I multiply this out, I've got x times x is x squared, okay, minus 3x plus 2x gives me my negative x in the middle, minus 3 times 2, minus 6. So I've factorized correctly. So the final thing I need to do is use the zero product principle, and if x minus 3 is equal to 0, then very straightforwardly x must equal 3, and here x must equals minus 2, or negative 2. So that problem is solved. I'm going to finally do one that won't work out so easily. So just so you can see a problem that isn't so neat, that won't work out so neatly, so that we can always think through any difficulties that come up. Let's have a look at something like this. So, problem D. Yeah, let's try this one. So we've got 2 over x minus 5 here, plus, and let's just keep it pretty straightforward, x plus 1 equal to 3. Okay, so I've deliberately chosen slightly more awkward numbers, but they don't look any different to the problems that we had in B and C. Let's see how it works out though. This is a quadratic equation. We've got to rationalize the denominators, turn it into an x squared polynomial, and then we'll be able to see what's going on. Okay, first things first, let's get our denominator. So x minus 5, x plus 1. And if I draw my fraction bar here, we're then going to have 2x plus 2, I'll do that straight away, just multiplying out the brackets, plus x minus 5 equal to 3. Alright, what next? Multiply out the denominator. So we've got, well, might as well do the numerator as well. We've got 2x plus x is going to be 3x, and we've got 2 minus 5 is minus 3. So that was nice and straightforward. What about the denominator? So I'll gather like terms at the same time. So x times x is going to give me x squared. X times 1 is x, minus 5x gives me minus 4x. And minus 5 times 1 gives me minus 5, equal to 3. So there we are. That's given me, that's joined them together, but what I need to do is rationalize the denominator. So it's simplified, but we now need to multiply out. So we've got 3x minus 3. is equal to, now I can just again multiply out without doing the brackets, so skipping that step, so just 3x squared minus 3 times negative 4 minus 12x, and then 3 times minus 5 minus 15. And then put an equal to 0, 3x squared minus 12x minus 3x gives me minus 15x here then. And then I've got minus 15 plus 3, so it's going to be minus 12 equals 0. Okay. So when I've got to this stage, it's simply a question of using the quadratic formula. It's a good idea then to use this discriminant. Let's have a look at what happens when I do that. So I'm going to change colour actually, so you can keep this on the screen to look at. So we've got our discriminant here. I use this space here, so give ourselves plenty of room here. So the discriminant is going to be what? So b is minus 15, so I'm going to square my minus 15. Minus 15 times minus 15 is 225. Okay, so far. Now, minus 4 times 3 times negative 12. So I can see this is going to turn out to be a positive, so it can be solved. By the way, if it had turned out to be negative, then we would say there are no solutions. It can't be solved. If it had turned out to be 0, which is another possibility, quite unusual, then we'd only get one solution, because the curve, if you were to graph this out, the parabolic curve would be just touching, rather than crossing it, would be touching the x-axis, giving you one solution. But I can see this is going to, these minuses are going to cancel out, so we're going to get positive. So we're going to get two solutions for x. All right. Let's work this out then. So we've got 225 minus, although it's going to be positive, so I might as well change that to be a plus. So we've got 3 times 12, well that's going to be 36. Times 4 means double it and double it again, so 36, 72, 144. 144. And when I add that up, we're going to get what? 360, 5 and 4, 9. Now, the reason why I deliberately chose these numbers here, this particular problem, is because I knew this would work out like this. It's going to be solvable, it's going to have two solutions, but the discriminant not being a square, so there is no there are no integers that when I square them will give me 369, so this is not a square number. And because this isn't a square number, I know I can't factorize. So I'm going to use the quadratic formula. No problem. Okay. So using the quadratic formula, take my discriminant. So let's put x equals, leave a little gap. Take my discriminant and put 369 now under the square root 9 of the quadratic formula. And then I put my plus minus sign in front of the radical. Now I need minus b. Well, what's b? b is minus 15, so minus b will be minus minus 15, which is positive 15. So I just put 15 here. And underneath, I've got 2 times a, so that's 6. So I simply need to use my calculator to work this out now. 15 plus the root of 369. Now, 369 square root turns out to be 19.209 ... So I'm going to rewrite this. Have I got room here? Yeah, let's just write it here. 15 plus, and I have to use my calculator here. So my calculator tells me it's going to be 19.209 ... Okay. Sorry, and obviously I don't need a square root sign, so that was my little mistake there. There we go. Let's rewrite it. Okay. So 19.209, that gives me more room. There we go. divided by 6. And on the next line, I can then split these apart. So I've got x equal to 15. And let's do the minus first. So we've got minus 19.209 divided by 6. Or x equals 15 plus 19.209. Now obviously I could have skipped a step here, but I just wanted to show these two solutions very clearly before I simply gave the answer. So here we've got minus 4.209 divided by 6, and here we've got x equals what's it going to be? 34.209 divided by 6. I'm running out of room here, but I'm going to use my calculator now. So 4 divided by 4.209 divided by 6 gives me 0.7015, but I've got a negative sign in front of it, so it's going to be negative 0.7. Let's give that to just 1 dp. And it might be that they tell you the degree of accuracy, but here I'm just going to use 1 dp. And now I've got 34.209 divided by 6. What does that give me? 5.7015. So I'm going to give the second solution as 5.7 again to 1 dp. Okay. So just to finish this tutorial, I just want to say a few things about this degree of accuracy, which is a problem when it comes to exams. If we had the exam problem like this, let's put the problem then in this circle here. So I've got here from a textbook a problem x plus 5 over x, so it's a fractional. It's fractional anyway, here, at this part here, equal to 12, and they're offering 3 marks to solve, if you can solve this problem. The hint that they give is to look at the way the problem has been framed, and it says find the exact solutions. Okay, find the exact solutions. Now, if we're asked to find the exact solution, we're certainly not going to be rounding, so it means not rounded. Let's have a look at what happens here, and then hopefully this will become a bit clearer. So if I have, for example, x plus 5x equals 12. If I have this as my problem, I mean, how am I going to turn it into the quadratic that I know is sort of hidden inside here? Well, multiply through by x. So x times x will give me x squared, plus 5 over x multiplied by x will just give me 5, equal to 12 times x, which is 12x. So that then is going to give me x squared minus 12x plus 5 equals 0. There's my quadratic. Now, let's use our discriminant trick to find out what kind of methods we can use to solve it. So if let's do this. Let's do it down here. If I find the discriminant, then what am I going to use? B squared minus 4ac. So b squared is negative 12 squared. So that's going to be 144 to start with. Minus 4 times 1, because my x squared coefficient is just 1 times 5. So it's pretty straightforward here. It's equal to 124. Now, here we've got a slight problem in that we don't have a square number here. And if we don't have a square number, then our option of using the method of factorization is not available to us. So we can say we can't do that. That makes us think then about the quadratic formula. But as we've seen, the quadratic formula, although it will work, and it's certainly what we're going to use, often doesn't give us these nice tidy solutions. That's why we tend to resort to it. And yet so we would tend to round to 1, 2, 3 decimal places. But that's not possible because we want an exact solution. So how do we get an exact solution? Okay, let's work this through and have a look at this. So we're going to use the quadratic formula. We know that the discriminant is 124, so x must equal 124 under our square root sign, plus or minus, and it's minus b, so it's going to be 12 plus or minus root 124 divided by 2a, so divided by 2. Okay, now the problem we've got then is we're going to have to find, we can't use our calculator in a sense. We can't simply find the decimal square root of 124. What we might think about then is a surdic solution. So if we can't, if we have to keep things exact, surds are our friends. So we're going to have 12 plus or minus. Now what we want to look for under here then is a square. And let's think about this. Have we got 4? So 2 squared, 4. Well, 124 divided by 2 is going to give us 62, and divided by 2 again is going to give us 31. So we certainly have got 4. Have we got 3 squared, 9? Well, if we think of 9 and the digital sum, we've got 1 add 2 is 3 plus 4, so we can't get 9 out. 4 squared, 16. Have we got 16? Well, no, 16 won't go into 124. So, and if we keep going, 25 is clearly not working. Neither is not going to work, and neither is 36. So, but 4 does, and so we have some sort of simplification that we can do here. So let's pull out our 4. So our 4, square root of 4 is going to be 2. And then under the square root sign, what have we got left? Well, 31. So 31 add 31 is 62. Add 62 is 124. So 31 is our answer here. We've now got a denominator of 2. And let's see what we can do next. Well, if we split our answers into the two solutions, we've got 12 minus 2 root 3 divided by 2. Or we've got x equals, let's write x equals 12 plus 2 root, sorry, 31, not 30, not root 3, 2 root 31 divided by 2. And now to create a proper surdic quantity, all we need to do is divide by 2. So 12 divided by 2 is 6, 2 divided by 2 is 1, so 6 minus root 31. And on the right hand side here, 12 divided by 2 is 6, and exactly the same, plus this time root 31. So our solutions now are surds. 6 minus root 31 or 6 plus root 31 gives us an exact answer to the question.